Never give up. Let's start the class with new hope. Good morning, everyone. During hot season, what do you like to drink? Yes, absolutely, that is juice. In your home, there is no juice, but lemons are there. So, with the use of that, you are going to prepare lemon juice. How will you prepare? You are going to add 1 full lemon's extract with 2 cups of water and 2 tablespoons of sugar. While preparing juice, your friends enter in your home. So, you are going to prepare juice for them also. What you will do? Yes, you are going to double your ingredients according to your friends. Now, can you say what are the basic components present in lemon juice? Yes, they are lemon extract, water, and sugar. Similarly, each molecules are made up of some kinds of atoms. For example, water. The molecular formula of water is H2O. Components are hydrogen and oxygen. They are present in the ratio 2:1. So the actual ratio of the components in the molecule is called molecular formula, and the simplest ratio of the components in the molecule is called empirical formula. Let's see briefly about empirical and molecular formula in today's class. At the end of this session, you will be able to find the empirical and molecular formula of the compounds. Let's start the class. You are familiar with the topic molecular formula from your smaller class onwards, whereas the empirical formula is a new topic for you. Don't get worried about that. Let's see clearly in this class. Do you know the molecular formula of acetic acid? Yes, that is CH3COOH. Let's write the amount of atoms present in that acetic acid. So C2H4O2. That means in acetic acid, two carbons are present, 4 hydrogens are present, and 2 oxygens are present. So the actual atoms present in the compound is known as molecular formula. Let's write the ratio of the atom. What are the atoms? Carbon, hydrogen and oxygen. So C is to H is to O. The ratio is 2 is to 4 is to 2. This is a actual ratio. Now we are going to take the simplest ratio by dividing this with 2. So 1 is to 2 is to 1. This is the simplest ratio of acetic acid. With the use of this simplest ratio, now we are going to write that formula. That is, how much carbon is present? First atom is carbon, so carbon amount is 1. So C. Then hydrogen amount is 2, so H2. O also 1, so O. The simplest ratio formula is CH2O. This is the empirical formula of acetic acid. Let's differentiate the empirical and molecular formula and calculate the empirical and molecular formula. First, we are going to differentiate that with the use of its definitions. Molecular formula indicates the number of atoms present in the compound. For example, C6H12. Whereas empirical formula indicates the simplest ratio of elements in the compound. Let's write the empirical formula of C6H12, that is CH2. One more example for that, CH2O. Empirical formula also CH2O, because here we couldn't take the simplest form of that. In this sum, they are given percentage of atom in the molecule and molar mass of the molecule, and they ask us to find empirical formula and molecular formula. To find empirical formula, first step, find the mole. Second step, find mole ratio. Third step, obtain whole number ratio. Let's do the first step. In first step, we are going to find the mole for iron and oxygen. To find the number of mole, the formula is given gram divided by its atomic mass. So for iron, 72.35 into 1 mole divided by 55.845 gram. It gives 1.296 mole. For oxygen, we are going to divide with the 15.99 gram. It's give 1.728 mole of oxygen. Next, we are going to find the second step. In second step, what we are going to find? We are going to find the mole ratio. To find the mole ratio, we need small answer. So among these two answer, who is a small answer? 1.296 is a small answer. So with the use of this small answer, we are going to divide both answers. And finally we get 1 and 1.33. Is this two answer also whole number? No. In third step, we need to find the whole number ratio. But in second step, we got only iron is a whole number, but oxygen is a fraction number. That's way we have to convert that fraction number into whole number. To convert this, we have to multiply that fraction number with appropriate number. So if we multiply that 1.33 with 3, we can get whole number 4. But if you multiply with 1.33 into 2, it's give 2.66. Again it's a fraction. So we have to multiply with 3. We get answer as 4. For iron, already it's a whole number, but oxygen we multiply with 3. No, that's way we have to multiply the iron answer also with 3. So it's a 3. Now we got whole number ratio for iron as well as oxygen. Let's write the empirical formula, that is Fe3O4. Next step, we have to find the empirical formula mass. So empirical formula mass or formula mass is equal to 231.531 gram per mole. After that, we have to find the molecular formula. To find the molecular formula, we need N value. That N value is find by N equal to molar mass divided by formula mass. Molar mass already given in the sum, that is 231.5 gram per mole. is divided by formula mass 231.531 gram per mole. So if we cancel, we get 1. So molecular formula N into empirical formula. So N value is 1. 1 into Fe3O4 gives Fe3O4. So molecular formula also Fe3O4. Let's recall today's class. Today we have learned molecular formula and empirical formula, and then how to calculate the molecular formula from empirical formula. Let's think and answer for my question. What is empirical and molecular formula? Thank you.